You there? Oh, the internet is thinking.
Hey, how's it going?
There you are, Dr. John Urschel. How are you?
I'm good. How are you?
I am absolutely fantastic, and I am in the back of my mind saying, don't talk about how big of a fanboy you are right now. So I'm doing my best to calm my nerves.
Okay. Okay. Yeah. No worries.
Where are you? Are you right now? Are you at MIT or are you at
Yeah. I'm at
Princeton?
MIT.
Okay, because I read somewhere where you were working at the Institute of Advanced Studies at Princeton as well.
Yeah, I was there last year.
Okay, that's amazing. By the way, I just interviewed um Dr. Deline. Did you
Oh
ever
yeah, yeah,
interview him?
Pierre. Yeah, yeah.
He's a very lovely man. He's fantastic. So I
Yeah.
have a couple of questions, and then I have a lightning round for you, and I'm going to try my best to keep this as short and as sweet as possible because you are incredibly busy. So
Okay.
I put 19 questions in a hat. That's going to come back to play later, and I'm randomly selecting these 19 questions. Okay, here we
Okay.
go. First up, um, you were born in Canada, grew up in upstate New York. Your mom, in an interview that I saw, said that she had you calculating change when you were 5 years old, and if you calculated correctly, you got to keep it. So you had an early aptitude for mathematics. Were you a part of a gifted program whenever you were in high school and in middle school?
No, no. So I was also I don't even know if I was like gifted for math. I just kind of liked quantitative things. I like puzzles, I like games. And so when you like something, you do a lot of it. And when you do a lot of something, you get good at it. And
Right.
so I spent probably, like, if I had to guess, when I was a little kid, I probably spent four, maybe five, or maybe even six times as much time on math as a normal kid would.
Really?
So when you spend that much time on math, like, you have to, like, you get good at it. Like, this is kind of like all I did. Like, I would come home and I would just like do puzzle books,
Yeah.
like Martin Gardner type puzzle books. I would do like math workbooks for fun. My mom and I would play like math games. Like, we would do that change game at the store. And then when I got like good enough at that, we started doing like the calculating the actual amount with tax. So I got good at multiplying by eight because, well, that was the tax rate in New York State at the time. So
Right. That's
yeah, so I would say it was more just that it's what I like doing. In high school, I had the chance to be a part of, in Buffalo, there's this program, I forget what it's called, but the idea is you take math classes at the University of Buffalo, and it's like an accelerated sequence. But I was an athlete, and it took place like after school,
oh, okay.
and so I couldn't take part. So I definitely took advanced math classes
Right.
throughout, but I never did a specific like gifted program or anything.
Interesting. Okay.
Yeah.
Wow. Okay. In one of your talks that you gave at MIT a few years ago that I found, you talked about how receiving criticism from your peers at MIT and giving criticism is part of this, iron sharpening iron kind of idea. And
Yeah.
I wonder, at what point did you become comfortable receiving criticism? And at what point did you become comfortable giving criticism?
Grad school. When I
Okay.
got to grad school, this is when I got to graduate school in math, it's a time where somehow like everyone's focus naturally shifts, because sometimes in high school or even in undergrad and college, you have this sense that you're kind of competing with people. They're handing out grades, who's doing better at this, who's doing better at that, who's the best math student, who's better at math, because you're like sort of, there's
Valid.
always this
Yeah.
little underlying competition going on. But then when you get to grad school, grades don't matter.
Right.
This sort of like thing, like who's better doesn't matter. We're literally all here just to learn math and do research and try to discover and solve cool problems. And then it starts to become more collaborative, more us helping each other, us showing each other different things. because different people are better at different things, and different people know things that other people don't. And so I would say from grad school on, I've become very comfortable with, I don't know something as well as someone else, I go ask them first. Or if someone tells me they don't love the way I presented something that they know better than me, then I say, okay, thank you. And, if I know something better than someone else, I'll tell them, no, you should actually do it this way because this is a simpler way or something.
I find a parallel when it comes to teaching. There's two schools of thought, and I've worked I've worked in an urban area, and now I'm in a rural area. And at the urban school, there was this idea of, like, I don't want to say competition, but like, oh, my kids all got 78s on this standardized test, and
Yeah.
my class average was, and I feel like here we're more. I mean, there's only two of us, so it's more of a collaboration, and well, two and a half. I apologize. We have a part-time teacher, but it's more of a collaboration. Hey, how do you introduce this? Or hey, my students aren't understanding this. How do you do that? And so I wonder if it's the construct of grades that kind of puts collaboration on the back burner. That's an interesting.
Yeah, no, definitely. I mean, it's definitely involved. Anytime you're like giving people some absolute measurement where you're comparing them along the same axis, I mean, that just naturally breeds competition and sort of adversarial type approach,
Right.
at least in some people.
Right. Okay. Have you done your mathematical warm-ups yet for this morning?
No, but you can just jump me right in.
All right, here we go.
I haven't had my coffee yet, but I'm ready.
Okay. You were selected 175th in the 2014 draft, NFL draft.
Okay, 175th, yeah.
Can you name all the prime factors of 175?
All the prime factors of 175? 5, 5, and 7.
Great. Okay, good.
Oh, okay.
Bonus question. Can you name all the factor pairs of 175?
When you say factor pairs, it's things that multiply to 175?
Correct.
Okay, cool. So 1 and 175, 7 and 25, 5 and 35.
Perfect. Now for the double extra bonus, can you list all possible b values, thinking about the standard form of a quadratic?
Wait, all standard what values?
Standard form of a quadratic.
Standard form of a quadratic.
Can you list all the possible b values for a second degree trinomial where a equals 1 and c equals 175?
All the possible v values. Oh, I see. Yeah, I can. They are. Well, let me just go through my pairs. What were they? They were negative 176, they were negative 40, and they were negative 32. And then also I need to do the plus and minuses as well, which is annoying, which is a bunch more. I have to do plus minus. Yeah.
Yeah. Well, with a positive 175, those are the only 6. Yeah. Sorry, you're fantastic. So I was in one of the NFL Films things about you, the old guy who had you, it might have been the Bryant Gumbel.
Bernie.
Yeah,
his name Bernie. Yeah, I think it's Bernie.
Yeah, he was talking to Joe Flacco, and it was just like, hey, we have to take a dig at this guy because he's perfect at everything, right? So Flacco's talking about how you missed snap counts and all sorts of other stuff. So it got me thinking, in this classical sense of the absent-minded professor, do you ever find yourself thinking about math problems or the current problem that you're working on when you should be doing something else? Like if your wife asks you to do the dishes and you sit there for 5 minutes and then she says, honey, go do the dishes. And you're like, I didn't know you needed me to. Do you ever find yourself going through that?
I do, but I'm not sure it's like the absent-minded professor. I think it's just genetic.
Yeah.
Because my daughter's like this too, and she's not a professor yet. Like, sometimes she gets wrapped up in something, or she's working on, maybe she has a puzzle she's working on, or something she's trying to solve, or something she's trying to figure out. and she just gets focused, and my wife might say something and she might just not hear her.
Okay.
Yeah. So, but usually when I'm supposed to be doing other things, I'm doing other things. Like, okay, if I'm walking to work, I might be thinking about math while I'm walking to work, but I feel like I'm
That's safe.
capable.
Yeah,
Yeah, but
that's
not.
safe.
I don't think about math while I'm crossing the street.
Right.
Yeah.
Right. Yeah. Or if your wife's trying to ask you, what color centerpieces you want on something, and all
Yeah.
you can think about are eigenvalues for some, some crazy matrix. So Jim Gaffigan, do you know who Jim Gaffigan is? He's a stand-up comedian.
Oh yeah. The name sound. I think I have a picture in my head.
Yeah, yeah. So, very pale is his own joke, but he
Yeah,
has a joke that goes, it's about fruitcake, and he says there's a big quandary because fruit good, cake good, fruitcake is nasty crap, right?
that's true.
And so I heard that joke. I thought that joke was absolutely hilarious, and then like a week later, I walk into my elementary linear algebra class. And
Okay.
when I walked in, I thought, linear, easy, I got that. Algebra, I'm confident. Linear algebra, the hardest thing I've ever had to try to do in my life, right? It was really tough. Like it just seems like mathematicians just took two things and like stuck them together to like fool me into thinking I was going to be successful. That course, it was the first time I really, really, really struggled. So
Gotcha.
do you
Yeah,
remember?
that happens for a lot of people.
Really?
And
Okay.
yeah, like linear algebra is definitely a big bottleneck for a lot of people. And I think, yeah, I think sometimes like the way we present linear algebra isn't always the best because in some ways, because it isn't, but some ways it should be the easiest math.
Right.
Like in some ways, calculus is really, really hard. And things like differential equations can get really, really hard. And
Yeah.
in general, so many things we try to solve in math are like really complicated. We don't know how to solve them. We don't know how to do things. But the thing that we all know how to do is we know how to solve equations for a line.
Yeah.
And so, like, so much of math is taking something complicated and converting it to linear algebra. Like calculus, derivatives is taking something complicated
Right.
and reducing it to the slope of a line.
Or the zero product property, right? Taking a quadratic and turning it into two linear equations quickly. Yeah.
Yeah, exactly.
Yeah.
Like so much of high level math is taking something very complicated and then linearizing.
So that I feel like we're kindred spirits because I keep trying to tell my students like that's the goal of math is to take something like so like you see all these different variables and this and that and all you want to do is you want to whittle it into like 5x minus 7 equals 0. Like that's what you want,
Yeah,
right?
exactly.
Okay.
Yeah, and if you can't do that, like you usually settle for like the closest thing. Like when you're solving polynomials, like okay, you're not going to be able to get it like linear, but what's the closest thing? They do these things like called Grosvenor bases, which is like Gaussian elimination, but for polynomials. Like,
Oh,
yeah, this
okay.
is yeah. So it just I don't know. I feel like it shows up like that everywhere, but it doesn't get taught like that. But
Right.
anyway, continue. You have
No,
more
and
questions.
when you said Gaussian elimination, I'm like, oh yeah, we do that at the high school level, right?
Yeah,
We
yeah.
would teach matrices. We're like, oh yeah, all you really want is you want the main the main diagonal as ones, and here are your rules. And oh, if you remember when we did systems of equations back your freshman year, and you had two rules, right? Those two rules are you can add the lines or you can multiply by a non-zero number. Those are the same rules that we're playing with matrices. Like it builds and builds. But then, I get that. I go to linear algebra and I'm like, vector space, who's this space? I don't know why I'm in space now. Like I didn't even get my astronaut suit. Okay.
But the Gaussian elimination is still there. It's like a hilarious
It,
thing.
it is.
No matter how complicated the vector space gets, so many things will break. And like distance might not exist. The idea of like angles might not exist. The one thing that always exists is Gaussian elimination.
Really.
And there's this in like a lot of vector spaces, it's the only thing we know how to do, which is kind of hilarious.
That's crazy. So when I'm asked, why do you love math?
Mhm.
Um, I always turn back to this idea, and it's evolved, and I finally simplified it into math hasn't lied to me. I haven't been lied to when it comes to mathematics. It's always it either it is or it isn't, you know, and it either fits the definition or it does not. It breaks the definition.
Mhm.
There's no lying when it comes to that. Have you
Mhm.
found that to be true whenever you get further and further and further up the chain?
Yeah, yeah, I do. I mean, one thing that gets more difficult the further and further you get is because you're building on so many different things. Sometimes it can be tough to make sure there's not any like cracks in the foundation
Hmm.
because you're using so many things that have been built up over so many years, and important things have really been checked and verified and are solid. But then newer things or things that have only been used like maybe 100 times, sometimes there can be like little cracks and flaws. And so that's one thing that the further you get in math, someone may tell you something's true and 50 people may have believed this person,
Right.
but it might not be true. And there's a lot of verifying for yourself.
Yeah, you call them cracks and flaws. I call them nooks and crannies, right? So
Mhm.
when I teach something, I have one student in my mind who whenever I go over a concept and I'm teaching a concept, he will immediately race to the corner, the intellectual corner of the problem and say, well, what about this, right? So and I'm like, good. So you found that you're immediately you're like, great, the meat and potatoes are fine, but what about the edges? What's going on in the
Yeah,
nooks and the crannies of that idea? How could I possibly break this idea? And so
exactly.
it's really interesting that, since you're dealing with newer ideas, there's less and less people who's experienced them, so the nooks and crannies haven't been explored yet. So that's fascinating, really fascinating. Okay. I have a couple more and then we'll do a lightning round if you don't mind. I
Sounds
seriously
good.
appreciate your time. You're so
Yeah.
generous. Thank you so much. Um, have you well, I'll say it this way. What mathematician have you met that made you starstruck or that you felt like kind of like a fanboy?
Ooh, that's a difficult one.
Yes. Yes.
I I got quite starstruck the first time I met Peter Shor at
Okay.
MIT. So Peter Shor is the person who came up with what's called Shor's algorithm,
Uh-huh.
which is an algorithm to factor numbers
Okay.
into its prime factors. So if I give you a number and I say, hey,
75.
can you please tell me its prime factorization? We don't actually know how to do this quickly. This
Okay.
is like a problem we don't know the answer to. It's like one of the biggest problems in math. But if I ask you to solve the same problem, but I give you a quantum computer, you can solve it quickly. And Peter Shor is the person who came up with this algorithm.
Okay.
Yeah,
Wow.
so it's a beautiful, beautiful algorithm. And yeah,
Oh, that's cool.
the idea that factoring is like very difficult is an idea that like I think a lot of people don't know. Like when I was growing up in school, like I think, oh, factoring, yeah, that's easy. I always know how to do that. But it's actually very hard to come up with a systematic way to factor if you try to think about it. Like when you factor intuitively using informal rules for
Yeah.
small numbers.
Like, is it even? Do the
Is it
numbers add
even?
up to the numbers add up to something divisible by 3, right? So you do the 1 through 10 tricks. Yeah.
Yeah, exactly. So you can do 1 through 10 tricks very easily, and then you go from there, and then you start doing some guessing. But if you try to like take that idea and generalize it to really big numbers, there's like no good way that we know of.
Wow.
So, but
Wow.
on a quantum computer, you can do it quickly.
Right.
Yeah.
That's cool. Cool.
Yeah.
Um, do mathematicians actually use Wikipedia or did my professor try and pull my leg?
I use Wikipedia all the time. If there's something and I don't know what it is, the first thing I'm doing, Wikipedia, that thing of math I don't know.
Okay.
Yeah, it's probably the most, it's the resource I use the most, I would say.
And he said that it was the resource that is, I would say, policed the most. I guess is the best way to put it.
Yeah, I think it's quite well policed.
Yeah, do because I mean, who's looking up those those
Yeah,
topics,
we are.
right?
So
It's mathematicians, and generally you have to trust those people. Okay.
yeah,
Um,
and yeah, yeah.
you have I might pronounce this wrong, but you have an Erdos number of 4. Have you heard of this yet?
Yeah, I know the Erdős number. I didn't know my number's 4.
Yeah.
Yeah.
Oh,
Okay.
well, now you know your number's 4.
Yeah.
It's the Kevin Bacon of mathematics,
Yeah,
right?
yeah, exactly. Yeah. I know Erdős number. I didn't know my number was, I
Yeah.
think I knew at a time it was 4. I'm surprised it's still 4, but I guess I'm slacking.
I mean, this is. I mean, I've just been doing research since last night, so I've been doing
Oh,
my homework since last night. So
well, let me check.
okay.
How do I look this up? There must be a
I don't.
website for this.
I'm sure there is. I
Uh,
just took the information when I found it.
okay, let's see. Oh, do I have access to MathSciNet? Oh, maybe I do. Um,
I mean, if not, you're at MIT. They can get you access there.
John. Oh, authors. John C. That's me. Let's see. Oh, why is my picture still me playing football? I should try to change that. That's not good. Okay. Erdős number. How do I look this up? Oh, collaboration distance. We're getting somewhere.
Following students, please come to the office. Claire Hall, JC Roseberry,
My new Erdős number is 3.
Parker Slayman.
It is 3.
It is 3. It is 3.
Oh wow! Congratulations. Congratulations. Well, with that in mind,
Yes.
If I were to publish this on YouTube, could I possibly get an honorary Erdos number of 4 then?
Yes, I will allow it.
Well, okay, great. And so
Absolutely.
could you have like your assistant send me like a little plaque from MIT that says I have an honorary Erdos?
If only I had an assistant.
You got to get one of those. I hear they're great. Okay, I have two lightning round games that I want to play with you to kind of get
Okay.
to know you as a human being a little bit better. Okay.
Okay.
The first game is where were you when? Okay, and you have to name the place and the city that you were in. For example, if I asked you, where were you when when you found out your best friend, got a home run, you could say, my mom's basement in, Buffalo, New York, right?
Okay.
But also, if it's too personal, you're allowed to pass.
Okay.
All right. So the first one's kind of tough, and then it gets easier from there. Where were you when you found out about 9/11?
I was in gym class in Buffalo, New York.
Where were you when you met your wife?
Where was I? In a coffee shop at Penn State.
Where were you when you found out that you would have a theorem named after yourself?
Kind of
Your
pass, because when someone calls something after someone, it's sort of it's a continuum. It's a vague thing.
Okay, fair enough.
Yeah, so there's no time and place. But
Okay. Where were you when you heard the words, with the 175th pick in the 2014 NFL draft, the Baltimore Ravens select John Urschel, offensive line, Penn State?
I did not. And I was in my living room at Penn State. So they call you.
Right. They call you.
They call you and you start talking to them.
And so you're on the phone when that.
So I'm on the phone, you leave.
But
you're on the phone, you leave. You don't see the
like nobody gave you a clip of that for you to watch back.
No.
Really?
Yeah. So like I didn't see like with they select blah blah blah. No, I'm on the phone,
Oh, okay. So where were you when you got accepted to MIT?
Oh, I have no idea.
I figured that would be a huge part of your life.
I
tried to think of some major milestones.
I have no idea.
Okay. That's
Yeah.
good. Where were you when you found out that your wife was pregnant with your daughter?
I was at home in Baltimore on the phone with like one of my best friends, and she texted me. Yeah.
You found out via text message?
Yeah, it was on the phone. Yeah.
Oh man. I thought okay, so I have two kids, and my wife and my son were all sick with the flu for a week. And it was
Yeah.
Saturday morning. My wife comes crawling back into bed on a Saturday sleeping in day. And she goes, Dave, what do you want more than anything in the world? And I was like, I don't know, world peace, like no more war. And she goes, no, no, no. Anything more than anything. What do you want? And I was like, I don't know, to end hunger so there's no more like hungry kids. And she goes, no, Dave, I'm pregnant. I was like, oh. Okay, last lightning round, and then I'll let you go. And you thank you for being so generous. All right,
Yeah.
here we go. This is to kind of clear to get your quick initial reaction on some mathematical vagueness, so to speak, and life vagueness. So
Okay. I don't understand fully, but when you ask the question,
you'll catch it. Was math invented or discovered?
I think invented, but I'm not a math expert. Okay, sorry, lightning round.
Lightning, yeah. Let's. Yeah, that's a tough question, right? It makes me think. Was Baltimore crab cakes or Boston clam chowder?
Baltimore crab cakes.
Would you rather be a Super Bowl champion or a grandmaster in chess?
Oh, grandmaster in chess. That's way cooler.
Abel Prize or Fields Medal winner?
Ooh. Fields medal.
Okay.
Yeah, I want it sooner.
Iron Man or Spider-Man?
Spider-Man.
Archimedes or Euclid?
Euclid. You gotta love the elements.
Yeah, right. One of my students is going to be so happy you said that. Pokemon or Yu-Gi-Oh?
Pokemon. This is not even a.
Would you rather block for Patrick Mahomes or Tom Brady?
Patrick Mahomes.
Yeah.
No question.
Yeah. That's what's up. I'm from Kansas City, so I had to. Would you rather take a trip to the moon or a trip to Mars?
The moon. Mars sounds dangerous.
Right. I think you're right. Would you rather go on vacation to a beach or the mountains?
What time of year is it?
Right now.
Mountains.
Euler or Ramanujan?
Euler.
Yeah, I apologize. Better accent, Boston or Australian?
Do you say Boston or Australia?
Yeah.
I've never been to Australia. Australia.
But you've heard Australians, right? Like, you know the accents.
Oh, you're saying accent? Say this a question.
Yeah. Which is a better accent? Boston.
Oh, Australian. That's not even a question.
Okay.
Great accent.
The definition of a trapezoid: a quadrilateral with at least one set of parallel sides, or a quadrilateral with exactly one set of parallel sides.
Oh, I say at least.
At least. I love that, because then it's nested inside of. Okay, sorry. Star Wars or Star Trek?
Ooh, Star Wars.
Perfect. And finally, who gets credit for calculus, Newton or Leibniz?
Both.
You can't say that. You have to choose.
They have different they have different forms of different rules, different things.
I'm kind of okay with that.
I don't know history, so I don't know history, but I know both of them in calculus have techniques and ideas named after them. And if each came up with the things that they're named after, then I say and they did it at the same time, both get credit.
Okay, that's fair.
Because they're doing the same thing in different ways, which happens all the time in math.
I will allow that. But I just had the best time talking with you. I cannot tell you just how grateful I am for your time. And I will send you my address so that we can get my honorary Erdos number. And if you ever come to Kansas City, I would kind of have my feelings hurt if you didn't call me so I could take you to barbecue.
All right. I will let you know if I ever end up in Kansas City. I like the trapezoid question. Yeah. I think a rectangle is a trapezoid, but I don't know.
I like that idea too. And I have to teach my geometry students, I have to teach it in two different realms where a trapezoid is separate from parallelograms And then where another method where it's nested inside parallelograms, and I really enjoy the just
Oh, hold on. Now I understand your question.
because there's two different
They don't, I see. I think when I learned trapezoid, you have parallel sides,
Mhm.
and I don't know why, but intuitively, I always feel like the informal definition I was always taught is that one of the parallel sides has a pair of acute angles, and the other parallel side has a pair of obtuse angles. And so I've never thought about like an arbitrary parallelogram being a trapezoid.
Right.
When you asked that question, I was thinking like, is a rectangle a trapezoid?
Right. Yeah. Parallelograms would
Oh,
be nested within the idea of trapezoids if it was at least.
is a trapezoid
Only isosceles trapezoids would have a pair of acute and a pair of
right?
obtuse.
Yeah. A parallelogram is a trapezoid. Yeah.
If you subscribe to the at least. Now, if you subscribe to the exactly, it's in its own little category, kind of like a kite
Right.
in the family of quadrilaterals.
Right. Yeah. Okay. Yeah, I'm on board. Yeah, trapezoid, at least one pair of well, you don't even have to say at least. Trapezoid, a pair of parallel sides.
Right.
Yeah.
A pair. Yeah, but
Yeah, a pair.
yeah. But
Yeah, I like it. I like it.
But now I'm uncomfortable because I don't know where to put it. Like, do parallelograms now belong with trapezoids or do they not? And since you're a professional, I would really prefer it if you got to the bottom of that just to satiate my mind. That would be great.
Yeah, now I want to get to the bottom of that. I mean, trapezoids are the sort of thing that I haven't encountered or thought about in so long, but now I'm really interested to think about this.
You have no idea. You have I'm forever a fan of both the fact that you played in the NFL and you're a mathematician. I have a ton more questions. Do you have time for one more math question by chance?
Yeah, ask one more math question.
All right, so here it is. I started with 19 questions.
Okay.
And before we got to the lightning round, okay, so before the lightning round, I started with 19 questions. I asked 7 questions.
Yeah.
How many different possible ways are there that this conversation could have gone?
Isn't it 19 choose 7 times 7 factorial? So it would be like 19 factorial divided by 13 factorial.
Yes. I mean, it would be a permutation because
we're not 13. Yeah, 12 factorial. Sorry, I should know how to subtract. Yeah.
Right, but it's a permutation and not a combination because order matters, right?
Right. So it's just 19 times 18 times 17 times 16 times 15 times 14 times 13.
Correct.
So that's like 19 factorial over 12 factorial.
Correct. Yeah, that's it. And whatever that number is, it's huge.
Yes. Yeah. Very, very big.
Yeah, I mean, I'm just fascinated with how fast factorials grow. It just
I forget. It's
not intuitive.
I think it's 20. So I always like to play this game when I think about, because sometimes I talk about computation and sometimes I'll like talk about, factorials. And I think if you have some problem and a factorial is involved and you want to solve it exactly on a computer, like, the fastest way to visit 20 cities, I think 20 is the sweet spot, that if you checked every single one, all 20 factorial, and it took you a second to check each one, that would take longer than the history of the known universe, I think.
Right.
I think 20 factorial is like where it breaks that threshold.
Right. And the other one that absolutely fascinated me, and I actually erased it off of my lightning round. The other one that's fascinating about factorials that throws me is there's more ways to shuffle a deck of cards than there are atoms in the world.
Yeah, definitely. Yeah. In the that
crazy.
That I believe.
That is bonkers.
Yeah. No,
when you first hear
it's
it,
crazy. It's crazy how much
an atom, right? There's like a billion between my fingers, but You know,
Yeah.
there's more ways to shuffle a deck of cards. 52. That's crazy. Okay, I apologize for stealing so much of your time. You've been so generous with me. I very much appreciate it. You will be getting an email from me later on this afternoon with a video of this if you ever, whatever you want to do. And I can't thank you enough for your time and energies, and I really hope my students get a chance to connect with it.
Oh, sounds good.
Yeah. Thank
All
you
right,
so
have a
much.
good one.
Bye, Dr. Urschel.
All right, bye.